morning, grade 9 students. Today I'm going to start our revision, inshallah, for the third quarter. I'm going to revise and use the presentation slide by slide. So you have to prepare your presentation, and I'm going to mention the number of the slide which I'm talking about it. Here's the first lesson. The first lesson is talking about electrostatic charges. So we have some physical terms like electrostatic charge, neutral, what's the meaning of neutral, what's the meaning of insulators, and what's the meaning of conductors. You have to know this physical term meaning and how to define it. In the first slide, evidence of charges. So you have to define or know what's the meaning of electrostatic charge, what's the electrostatic charge, and how to define it. Electrostatic charge are charges that are collected in one place due to as a result of friction. We know we have two types of charges, even to be positive charge or negative charge. The similar charge repel each other, and the opposite charge attract each other. Like repel like and unlike attract each other. For the first slide, I was talking about the definition of electrostatic charge, and also talking about the type of charges and how they interact with each other. For the second slide, we have the number of protons that equal to number of electrons. So an atom is neutral as both of them is equal to each other and have different opposite charges. So the atom is neutral. So you have also to know this information only from this slide. For the third one, it's a way to show how to make electrostatic charge by different charge, even to be positive or negative as a result of friction. But I don't like it. You can read only this page. The slide is for reading only. I'm not going to ask you about it. The next one is talking about conductors and insulators. You have to know what is the difference between conductor and insulators. Conductors are substances that conduct electric current, made up of metals, and these metals are able to conduct electric current. As a result, they have extra amount of electrons. They tend to lose these electrons, so it's able to conduct electric current or to make the charge flow from one atom to another atom. For bad conductor or insulators, made up of non-metal, they tend to gain electrons to complete the outermost energy levels, so they are unable to make the charge flow from one atom to another atom. For this slide, خلاص كده. Conductor and insulators also we've done with the first presentation. So the first presentation can describe the first lesson, which describes the first lesson, electrostatic charge. We have four physical terms. The first one is electrostatic charge and how to form electrostatic charge and the meaning of electrostatic charges. Neutral atom, what is a neutral atom? Insulators and conductors. Let's move to the second presentation and review it. For the second lesson, guys, which is called electrostatic forces, we have also different physical terms. I'm going to explain it quickly. The first one, electroscope, charging by conduction, charging by induction, grounding, what's the meaning of grounding, Coulomb's law, Coulomb constant, elementary charge. Right. Electroscope. Electroscope is a set used for prove that the similar charges repel each other and the opposite charges attract each other. In the first slide, we have something like a small experiment to show how opposite charge attract each other, and similar charge repel each other. So you can read this page, and the only information you need to know from this page, from this slide, how the opposite charge attract each other. The electroscope is for reading only, to know that the charge can move through the conductor from one place to another place. The electrostatic charge can move from one material to another one by a method called conduction, when the two objects touch each other. The third slide also. The third slide also explains the meaning of conduction. You have to know only that the charges can move from a charged particle or charged object to another one, neutral one. Which is mean, if you have a charged object, you have a charged one with positive charge, and you're going to approach it to another one, which is neutral. So the charge is going to move from the charged one to the neutral one by a method of conduction. If they are going to touch each other, and the other one will be positively charged, will change into a charged object, positively charged. If you're going to approach a positively charged object to another one, is already charged object, to be even positive or negative charged object, the charge in this case will not going to move from one object to another one. They are going to repel each other, so the charge will be collected in this side away from the other part, خلاص? And this charge is going to be collected, moved, pushed to the side of the conductor or the substance itself. If you're going to add another one with opposite charges, here's the opposite charge going to attract each other. So the charges will be collected in the side of the object near to the opposite charge. They're going to collect in this way, in this direction, as they attract each other. The only way, the only method to make the charge move from one object to another, one of them be charged and the other one not charged, is neutral. In this case, the neutral object of the neutral substance able to accept charges from the charged one. And we have another method also for moving charge from one object to another object called induction. This method of induction, that when without touching each other, moving of charge. So if we are talking about induction, the method of induction of transferring the charge from one object to another without touching each other, like the spark happen through the air. The next slide is a video. Next one explaining what I already explained on board. Coulomb's law. Coulomb's law is a relation between the charges of objects, the distance between them, and the force of repulsion or attraction between them. Coulomb's law is force equal Q1 times Q2 divided by R squared times K. Q1 is the charge of the first object. Q2 is the charge of the second object. R is the square of the distance between the two charges while K hold Coulomb's constant, which equal to 9 times 10 of power 9, and you have to know the unit, which is equal to Newton times meter square per Coulomb square. Coulomb measured, or the charge measured in Coulomb, R measured in meter, force measured in Newton. I'm going to write a problem to solve it. The problem is going to be direct substitution. And I'm going to write it in simple numbers to be able to understand it quickly. Okay, guys. Find the force located between two charges. Each of them is 30 coulomb, and the distance between them is 2 meters. As I told you guys, I'm going to use simple numbers to make the calculation more easy. Right. First of all, we have to find the givens. The givens here. Find the force. Find the force. I need the force located between two charges. Each of them is 30 coulomb. Each of them, first one is 30 coulomb, and the second one also 30 coulomb. And the distance between them are equal to 2 meters. Using Coulomb's law, force equal to K Q1 times Q2 divided by R squared. So easy on direct substitution. The value of K are already knowing it. You have to memorize it. K equal 9 times 10 of power 9 Newton times meter squared per Coulomb squared. So 9 times 10 of power 9 times 30 divided by 2 squared. So it will equal to 900 times 9 over 4. Don't have a calculator right now. I have it. It will be 2025. 2025 times 10 of power 9, or we can write it like that: 2.025 times 10 of power 12 force measured in Newton. So I think now you have, or are able to know how to solve this problem. So easy, only direct substitution, and you can solve it easily. Right. The next slide. The first one was Coulomb's law. The next one explains repulsion and attraction between similar and opposite charges. We have a problem. This problem for reading only. It has different steps. Some of them already explained in the previous quarter, but I'm not going to ask you about like a problem in this exam. I'm not going to bring one like this in the exam. So just read it, guys. We have also the idea of grounding. The grounding is a method to release. The grounding is a method to release the extra charge, electrostatic charges that gain by friction to the ground. To save our sets, to save our sets from being damaged, that electrostatic charge that collected in sets can damage it. So the grounding is a method to connect these sets to the ground, to release all of electrostatic charge that gained by friction or even by magnetic field to the earth and remove it from the set itself. I think we're done with the second presentation. The third lesson explains the properties of electric current, how to connect a circuit, what is the meaning of electric current, what is the conventional current and real current, what is the difference between battery and cell, the electric circuit, the ampere, the resistance, resistor, what's the difference between resistance and resistor, parallel connection and series connection. خلاص؟ طيب, let's take one turn by turn by turn. What is electric current? The electric current is the flow of electric charge through a conductor from one side to another side. To make this charge move through the conductor, you have to, or you need, a force to push this charge from one side to another one. This force is called potential difference. We have a conductor here. This one is wire or conductor. Conductor. In this side, we have a lot of charges. So we have a concentrated charges, area of charges. And this one, we have few charges. So the charge is going to move from the area of high concentration of charges to the area of low concentration. So it's going to flow through the conductor from side number 1 to side number 2. The movement of the charge itself called electric current. We have two types of electric current. Not two types, two descriptions of the current itself. Some scientists describe the electric current as the flow of electrons from one place to another place. The electrons form the electric current, so it depends on the movement of the electrons from one place to another. And it's the real current. The real current depends on the movement of electrons from one place to another. The conventional current describes the positive holes or the places left by the electrons. The real current is opposite to conventional current. As the electrons move from this side to another one, they're going to leave positive charge. So the conventional current going to be in this direction, opposite to the electric current, real electric current. So the conventional current is the movement of positive charge. Positive charges is the place left by the electrons. When the atom lose one electron, it turns into a positive ion. So the conventional current is the flow of positive charge from one side to another side. It's described as, if you have a battery, this battery connected with a resistor, the conventional current will be from the positive pole of the battery to the negative one. And the real current will be from the negative one to the positive. Here is the conventional. And here is the real. The force that push the electrons from one side to another one is called potential difference. And also it has another name called voltage. V is equal to the work done to transfer, V equals the work done to transfer amount of charges of one coulomb through the two terminals of conductor. The flow of electric current or current intensity is equal to the amount of charge that flow through 1 second. Current intensity is the amount of charge that flow between the two terminals of conductor, between 2 points of conductor, through 1 second. It's called current intensity. While R, which is called resistance, it's the opposite of the flow of electric current. The opposite of the flow of electric current can be calculated from the relation or from the ratio between the potential difference and the current intensity, which is called, by the way, Ohm's law. So we are able now to know and understand the three properties that control the flow of charges, the electric current through a conductor. The first one is called potential difference, the second one is called current intensity, and the third one is the resistance. Potential difference is the work done to transfer a quantity of charges from one coulomb between the two terminals of conductor. The current intensity is the amount of charge itself that moves through the conductor in 1 second. The resistance of a conductor is the ratio between the potential difference and the current intensity. The resistance of conductor depends on the length of conductor, its material, and also cross-sectional area. As the length of the conductor increases, the resistance increases. So the relation between them, they are directly proportional. As the cross-sectional of the area, the diameter of the conductor increase, the resistance decrease, so the relation between them is they are inversely proportional. They are inversely proportional. Right. What is the difference between battery and cell? The battery, guys, battery is a group of cells. The cell is a unit of battery. So the battery consists of different cells. To draw a battery, you're going to draw different cells connected together. The way of connection, the method of connection, we're going to study it later. But now we have to know that only one unit is called cell. Many units connected together called battery. Right. The measuring unit of potential difference is volt. The measuring unit of current intensity is ampere. The measuring unit of resistance is ohm. But you also need to know the difference between the alternating current and direct current. Alternating current and direct current. Briefly, we need only to know the definition. Alternating current is a current that has no direction. It has opposite directions, can flow in the opposite directions. It produced from magnetic field by something called from magnetic field by something called generators. Direct current resulted from electrochemical cells as a result of the flow of electrons from one atom to another one by gaining and losing electrons. We can collect this electron to form something called direct current. A direct current has only one direction. It resulted from electrochemical cells like a battery, while the alternating current resulted from a magnetic field using something like generators. Returning back to the presentation, slide by slide. The first slide, it describes what is the meaning of conventional current. You have to know the meaning of conventional current. Second slide describes the photoelectric cell and how to produce alternating and direct current. Third one describes the idea of generator and to produce alternating current. After that, we have the properties of electric current, which I already explained: current intensity, potential difference, resistance, factors affect the resistance, and what is the energy and power. You know that, guys, the work is the change in energy. From the previous quarter, we know that. But we are going to consider that the energy here represents not kinetic energy as we studied before, to represent the electric energy. Which is mean the electric energy is equal to work. We can find the value of work from V equal work over Q. So the work is V times Q. So the value of energy can be calculated from this relation. E, the energy, is equal to the amount of charge multiplied by the potential difference. We also know that, guys, power is the energy done by time, is the amount of energy done by time. So the power is equal to the amount of energy done by time. So we can say that the amount of energy QV divided by the time. Q over V represent I. So we can say also I times V. From Ohm's law, V equal I times R. So we can replace V by IR. So it will be also I square R. Or we can replace I by V over R, so it will be V times V over R to be V square over R. So we can calculate the power by different rules. Power is equal to Q V over T. Q is the amount of charge, V is the potential difference, and T is the time needed to make the charge move through a conductor, Also, we can represent it by the electric current multiplied by the potential difference, or the electric current squared multiplied by the resistor of the conductor, or the potential difference between the two terminals of conductor divided by its resistance. We need to know now what is the difference between resistance and resistor. Resistor is a component added to the circuit to control the flow of electric current, like a tap for water. So resistor is a component added to the circuit. We have two types of resistor. One of them is variable resistance, and the other one is constant resistor. Our resistor variable value, and the other one resistor with constant value. Here is a resistor with variable one. We can change its value. Here is a constant one. We cannot change its value. We have also a switch. Switch to close or open the circuit. Switch on, switch closed, circuit closed. Switch on means the switch is closed, and the circuit also closed, so the current can flow. Switch is off. Switch open. Switch is open. Circuit also open. No flow of electric current. Let's solve a problem on power. Find the power of a machine. That uses a current of half ampere and potential difference 220 volt. So it's so easy. Find the power. I need to know the value of power. Current intensity is half ampere, while the potential difference is 220 volt. So the power can be found from the relation I times V. I half times V 220 equal 110. Don't forget the unit of power is watt, and the unit of energy is joule. The unit of power is watt, and the unit of energy measured in joule. Measured in joule. Turning back to the presentation, we have different problems in this presentation. You can read it. Diagramming circuits. The component of the circuit, you have to know its shape. Also, Ohm's law, we explained that as a difference between resistance and resistor. We explained it. If we have a circuit like this one, it's a circuit, simple circuit. The circuit consists of a battery, a meter, resistor, and voltmeter. A meter is the set used to measure the current intensity. The ammeter is inserted in the circuit to be able to measure the amount of charges that flow through the circuit. Voltmeter is the set which measures the potential difference between two terminals or between two exact points. So I need to measure the difference in concentration between them. I'm going to measure the difference in concentration between two exact points. So I'm going to connect it in parallel over the circuit. This wave connection called parallel connection. This wave connection called series connection. I'm going to describe it later, but first of all, we have to know the job of the description of ammeter and voltmeter. Ammeter is the set which measures the current intensity. Voltmeter is the set which measures the difference in potential difference, the difference in concentration of charge between 2 points. Here's a circuit. The battery measured EMF of 12 volt and resistor measure a resistance of 3 ohms. What is the EMF, guys? Let's remember what is the meaning of EMF. EMF is the potential difference between two terminals of battery. Here is the battery. So I'm going to measure the potential difference between its terminals, called EMF. But remember that the potential difference to have an accurate value, the potential difference must be measured when the circuit is open. When the circuit is open. Why isn't the circuit is open? To prevent the flow of electric current. To have an exact value for the potential difference between the two terminals of the battery. So the EMF is the potential difference between the two terminals of the battery when the circuit is open. That means there is no flow of electric current through the circuit itself. In this problem, I'm going to ask about the reading of ammeter. What is the reading of ammeter? Right. The reading of ammeter is a set tool that is used to measure the current intensity. So simply I'm asking you about the current intensity. What is the current intensity? Returning back to Ohm's law, V equal I times R. We have this magical triangle V, I, R. I need the value of I, so it will be V over R. So I equal V over R. R is the current intensity, V is the potential difference, R is the value of resistance. Equal V, 12 volt, divided by 3, the value of the resistor will be 4 ampere. Right. We need to view another slide. The parallel and series connection. We have to explain the parallel and series connection. I'm also going to start the next lesson directly, as I'm going to merge both of them together. The connection of resistors, the connection of batteries together, cells together to form battery, how to define them, or how to connect them. خلاص؟ The wave connection. We have two methods. We can use them to connect the components of the circuit. One of them is called parallel connection, and the other one is called series connection. Parallel connection is a connection when the terminals of components are connected together, then connected to the battery. Or even, if I'm going to connect batteries or cells in parallel, I'm going to connect all the positive together and all of the negative together, then insert them to the circuit. Let's see that. First one, I'm going to talk about resistors. Here is a resistor, another one, and third one. If I'm going to connect all of the terminals of the resistor together, then insert them in a circuit. This method of connection is called parallel connection. Series connection, when I insert or connect one terminal by another terminal of the opposite direction for the terminal, for another component. If I'm going to consider this one is positive as connected by the positive pole of the battery, positive, negative. So I'm going to connect the negative by the positive one of the next component, the negative of this one by the positive, by the positive of the next one, and so on to finally the last negative connected to the negative of the battery. In the case of connection of resistors in parallel, the rule used to find the total resistance of this connection is 1 over RT equal R1, R2, R3. 1 over R1 plus 1 over R2 plus 1 over R3. For this one, the R total R1, R2, R3. يبقى R total will be equal to R1 plus R2 plus R3. Here is a wave connection for resistors. Also, we have another wave connection for batteries, for cells to form a battery. We are able to connect batteries in series or even in parallel. Here's a battery, a cell, another cell. I'm going to collect all of the negative poles together, negative, 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 and also all of the positive together. Then inserting them to the, connect them to the circuit, inside the circuit. The series connection is the wave connection, the first cell, connected to the second cell, connected to the third cell, then inserted inside the circuit by this way. Always the series connection is the best way, or is that not the best way, is the best of calculation. Simple calculation, has a simple calculation. I'm going to add them. So the EMF total, the voltage, will be equal to the EMF of the first battery or cell to the EMF of the second one to the EMF of the third one. We can use EMF as a potential difference inside the circuit, as the battery is the pump which pushes the electrons through the circuit components, so it's a potential difference. In this way, I only EMF is equal to EMF of the greatest value. Which is mean, if I have here 1.5 volts and also here 3 volts and here say 1 volt, so I'm going to use 3 volt as the EMF total. Usually I connect them in the same volt, but in this case I'm going to use the 3 volt as the EMF total. Right, let's solve the problems for this connection, for this wave connection, step by step. In this problem, he's asking for the value of the reading of a meter as, he's asking for I as, what is the reading of a meter, what is the reading, what is the value of current intensity, as each cell has a potential different, EMF of 1.5 volt and the resistance of 3 ohms. Here we have 3 cells. 1, 2, 3 cells. Each one of them is 1.5. So the EMF total will be 1.5 plus 1.5 plus 1.5, which means 4.5 volt. Type. Okay, now we found the total EMF. We found the total EMF. The total EMF equals 4.5 volt. To find the I, current intensity, we're going to use the relation or Ohm's law. 4.5 divided by 3 will be 1.5 ampere. Here 3 is the value of the resistance. Also, we can represent the connection by barrel connection. In the barrel connection, I'm going to use the value of the highest battery. So if each one of them is 1.5 volt, and the resistor is 3 ohm, like the previous one, so the EMF total in this case will be 1.5 volt. 1.5 volt, using the relation of Ohm's law, 1.5 over 3, it will be half volt. Ampere. Another circuit. .5 volt each one, 1.5 volt and 1.5 volt. So we have 3 cells. Each one of them is 1.5 volt, and 3 resistors. Each one of them is, let's say, 3 ohms. In this circuit, the batteries are connected in series, and also resistors are connected in series. So R total is the summation of all resistors. خلاص يبقى equal 3 plus 3 plus 3, 12 be 9 ohm. There's also batteries. خلاص V total or EMF total will be 1.5 plus 1.5 plus 1.5 equal 4.5 volt. I equal V over R, 3 4.5 divided by 9 will be half ampere. Another circuit. Each cell of 1.5 volt and R1 is equal to, let's say that 2 R2 is equal to 3, R4 is equal to 4. Each one of them by ohm, by ohm. Right. Here we have 2 types of connection. Batteries. Cells are connected in series to form the battery. So we are going to add the values. V1 plus V2 plus V3 اللي هي EMF1 plus EMF2 plus EMF3, the same meaning. So V total will be 1.5 plus 1.5 plus 1.5 equal 4.5 volt. Why the resistors are connected in parallel? The law of connection of parallel for resistors 1 over R total equal to 1 over R1 plus 1 over R2 plus 1 over R3 يعني equal to 1 over R1 يعني 1 over 2 plus 1 over 3 plus 1 over 4 is 1 over R total. Using calculator, خلاص we're going to find the value of R total. I'm going to find it. If 1 over R total is equal to 6, 3, 2, not 3, not 6, 12, maybe 12. 12 over 2 is 6 plus 4 plus 3. So it will be 13 over 12. So the R total will be 12 over 13. Oh. You have to convert it into decimals. Finding the I will be V total over R total. In this case, we need R total. Here is the rule 1 over R total equals 13 over 12. So we have to find the reciprocal of this term and this term. The reciprocal of 1 over RT, 1 RT, RT over 1, yes, I mean RT. The reciprocal of 12 over 13 over 12 will be 12 over 13. This value is almost 0.9 something. V total, the one which we found over 12 over 13, and find the last value by ampere. If you have a different wave connection, I'm asking you to find the total resistance of a circuit. The circuit contains the two types of connection for resistors. You have to finish them step by step. Let's see the following problem. The following problem is a resistor, another one, and here also two resistors connecting to a battery. Here, this one is 3 ohms, and also this one is mix them to only two resistors. Makes the calculation easier. خلاص 3 ampere, 3 ohms, 4 ohms. خلاص. This one is 2 ohm and 2 ohm. We have two types of connection here. These resistors are connected in parallel, and these resistors are connected in series. And the RT here, the total resistors, are connected in series with this one also. يعني البار ده is connected in parallel. Let's modify this circuit step by step. R total here, 1 over R total is equal to, for this part, 1 over 2 plus 1 over 2. So it will be 1 over 1, or 2 over 2. Make it step by step. 2 over 2 equal 1 over 1. So the R total now equal 1. This part is equal to 3 plus 4 equal to 7 ohms. Notice that, guys. We have two resistors, each one of them is 2 ohm, and they are connected in parallel. So the total resistance is less than the total resistance, less than the one of them. If there are two resistors, one of one and another one of two connected in parallel, the total resistance will be less than 1. 3 or 4 will be less than 3 if they are connected in parallel. The connection of parallel reduces the value of the total resistance, as the total resistance will be less than the lowest resistance inserted inside this connection. Here's the total resistance by adding the value of resistance or resistor, so the total resistance will be higher than the value of each one of the higher one inside the connection. Now we have two R total for the parallel connection and R total for the series connection. So here's R total of 1 ohm connected by the same way to another one of 7 ohms. So now these two resistors, we're going to consider them two resistors, are connected in series, so the R total will be the summation of their values to be 8 ohms. So the total resistance of this circuit is 8 ohms. Let's review the last presentation. If anything missed, I'm going to check it. Then I'm going to wish you good luck in your exam. The last presentation. Here's the last presentation. The last presentation is talking about superconductors, and the first part, superconductors and the way of transferring of electric current, and this part is for reading. I already read them inside the class, but just is for reading. These parts are for reading. Just read it. The river model for reading only also. After that, we have the series connection and the wave connections, connecting the meter, connecting the voltmeter. The connection. There's a part I forgot to say it. Series connection and parallel connection. In series connection, the potential difference not constant. It divides on the circuit component. While in the parallel connection, the potential difference is constant, as all of the components of the parallel connection are connected to the same point, so it's constant. Here in the current intensity, the current flow, the amount of charge that flows through the circuit is the same, so the current intensity over all the component of the circuit is constant. while here we have different branches. So the amount of charge divides into the branches, so it's not constant. It's not constant. The amount of charges divide on the circuit branches. The last one is the resistor. As we said, in series connection, خلاص resistor increase. In parallel connection, resistor decrease. Returning back to the presentations, the last presentation, the last lesson presentation. So the first part of this presentation is for reading. خلاص. First slide. Electrical energy, resistance, and power. We already done, and the second slide we done also. After that, providing electric energy for reading, and the wave connection also for reading. خلاص. River model, how the model of water, mountain, river, and the electric current are similar for the flow of water and the flow also of electric charge through a conductor, similar to each other, also for reading. Then the last part about series connection and parallel connection we're done. Good luck, guys, in your exam. Read well and take your time in solving. You have enough time. You have enough time to solve. So don't be hurry. Don't be nervous. Solve step by step. I'm going to have good morning, inshallah.